Winds, giant vortices, each unique in structure and behavior. The deeper Juno ventured, the more it revealed a planet not just chaotic, but harmonized by storms. To truly understand Jupiter, we must step back and view it as a planetary system, not just a single object. It's a world of layers, of cyclones, moons, magnetism, and ancient energy. One of the most captivating images from Juno shows Jupiter's south pole, taken from an altitude of about 32,000 miles. The scene is unlike anything in the solar system. Massive oval-shaped features dominate the frame, each one a polar cyclone, some over 600 miles wide. These storms spin in symmetry, maintaining balance in a way that defies simple meteorology. But Juno's mission wasn't limited to Jupiter itself. The probe also turned its instruments toward Jupiter's moons, particularly Io, the most volcanically active world known. Io isn't just a moon. It's a fiery, dynamic body that literally reshapes itself through continuous volcanic eruptions. Plumes of molten sulfur blast into space, visible even from hundreds of thousands of miles away. So what links Io to Jupiter's polar storms? That answer lies in the immense magnetic field of Jupiter, the strongest of any planet in our solar system. Io, orbiting within this field, becomes an electric generator, inducing currents as it moves, sparking auroras and possibly contributing to the dynamics of Jupiter's poles. What's even more fascinating is that these auroras, invisible to the naked eye, shine in ultraviolet and X-ray light, mapped for the first time thanks to Juno's instruments and Earth-based telescopes working in tandem. As Io spews particles into Jupiter's magnetosphere, they spiral toward the poles, creating massive energetic light shows deep in the atmosphere. Juno's data confirmed this interaction in stunning detail. Every time the spacecraft passed over the poles, it detected bursts of radiation, not just from internal heat or atmospheric convection, but from external interactions, especially from Io. In essence, the Moon and the planet are locked in a magnetic embrace, exchanging energy across millions of kilometers. And then came one of Juno's most astonishing discoveries. The polar cyclones themselves seem to shift subtly in response to changes in magnetospheric activity. Could this mean Io, and perhaps other moons, are influencing Jupiter's atmospheric structure in real time? The idea may sound speculative, but it's gaining ground. Scientists at Infinity Beyond note that the precise positioning of the cyclones and their long-term stability might not just be the product of atmospheric physics alone. Instead, it could be part of a larger electromagnetic system, a kind of planetary dance involving Jupiter's rotation, internal heat, and the gravitational and magnetic pulls of its moons. In that context, Io becomes more than a volcanic moon. It becomes a conductor, helping regulate energy through Jupiter's system. But Io's volcanoes also tell a story of their own. Juno flew close enough to detect thermal signatures from these eruptions, mapping hotspots across Io's surface. These aren't just small eruptions. Some volcanoes are hundreds of miles wide, blasting material so far into space that it becomes part of Jupiter's ring system. Yes, Jupiter has rings, faint and ghost-like, made partly from the dust and sulfur ejected by Io. All of this adds up to one mind-blowing realization. Jupiter isn't just a planet with moons. It's a planetary engine, and its moons are active gears in that engine. Every magnetic fluctuation, every burst of radiation, every volcanic tremor on Io, it all contributes to the story unfolding at Jupiter's poles. And Juno? It's the observer in the middle of it all, piecing together data to reveal the full architecture of this system. Even more intriguing, Juno discovered that the southern polar cyclones appear less stable than those in the north. Some are shifting in position. Some may merge. Why? Could it be the proximity to certain magnetic interactions? Could tidal forces from Ganymede or Europa also play a role? We don't have all the answers, but we do know this. No planet-moon system in our solar system behaves quite like this. Back on Earth, data scientists continue to analyze Juno's readings. Some are using AI models to simulate future changes in Jupiter's storm systems. Others are looking at similar signatures in exoplanets, suggesting that storms, magnetism, and volcanic moons might be universal traits in gas giants across the galaxy. This kind of science isn't just about looking outward. It's about understanding the patterns of motion, magnetism, and energy that connect celestial bodies. Jupiter and Io are the blueprint, a model of how seemingly separate objects can form a single living system. As Juno prepares for future flybys, scientists are preparing to use its final data to simulate Jupiter's inner layers, going deeper than ever before. And through this, they hope to answer a key question. What truly powers Jupiter, and how do its moons keep that engine running? Stay tuned to Infinity Beyond, where each new orbit brings us closer to the cosmic mechanics behind the largest planet in our solar system.